We have seen that every unit of speed has the same basic form, a unit of length divided by a unit of time. Examples include meters per second, kilometers per hour, meters per minute, and even centimeters per week. The next question is how to convert one unit of speed into another. Students often memorize this rule: to convert meters per second into kilometers per hour, multiply by 3.6. To convert kilometers per hour into meters per second, divide by 3.6. That rule is useful, but it is not enough on its own. If we learn it without understanding it, we can easily make mistakes with values such as 75 meters per minute or 8 centimeters per week. In those cases, we cannot simply multiply or divide by 3.6. We first need to understand what is actually being converted. A unit of speed has two parts. The unit in the numerator is a unit of length. The unit in the denominator is a unit of time. When a slash is used, the length unit appears before the slash and the time unit appears after it. Consider a speed of 108 kilometers per hour. The length unit is the kilometer, and the time unit is the hour. To express this speed in meters per second, we must convert kilometers into meters and hours into seconds. 1 kilometer equals 1,000 meters, and 1 hour equals 3,600 seconds. Therefore, 108 kilometers per hour becomes 108 times 1,000 meters, divided by 3,600 seconds. Now calculate the numerical value. 108 times 1,000, divided by 3,600, is the same as 108 divided by 3.6. The result is 30. Therefore, 108 kilometers per hour equals 30 meters per second. Physically, this means that a car traveling at 108 kilometers per hour covers 30 meters in 1 second. That is roughly 1/3 of the length of a football pitch. This gives us a useful mental picture of the speed. Now we can see why the number 3.6 appears. 1 meter per second means that an object travels 1 meter during every second. 1 hour contains 3,600 seconds. If the object maintains that speed for 1 hour, it travels 3,600 meters. 3,600 meters is 3.6 kilometers. Therefore, 1 meter per second equals 3.6 kilometers per hour. This is the meaning behind the rule. We do not multiply by 3.6 simply because someone told us to. The factor comes from the fact that 1 hour contains 3,600 seconds, while 1 kilometer contains 1,000 meters. In fractional form, 1 meter divided by 1 second corresponds over 1 hour to 3,600 meters per hour, which equals 3.6 kilometers per hour. Therefore, when converting directly from meters per second to kilometers per hour, we multiply by 3.6. For example, 10 meters per second equals 10 times 3.6, which is 36 kilometers per hour. Physically, if an object travels 10 meters during every second and maintains that speed, it travels 36 kilometers in 1 hour. In the reverse direction, when converting directly from kilometers per hour to meters per second, we divide by 3.6. For example, 72 kilometers per hour divided by 3.6 equals 20 meters per second. Physically, a car traveling at 72 kilometers per hour covers 20 meters during every second. However, the direct 3.6 rule applies only between meters per second and kilometers per hour. If the starting unit is meters per minute or centimeters per week, we must return to the basic idea: convert the length unit, convert the time unit, and then calculate. Consider 75 meters per minute. We want to express this speed in kilometers per hour. 75 meters per minute means 75 meters during 1 minute. 1 hour contains 60 minutes. At the same rate, the distance corresponding to 60 minutes is 75 meters times 60, which equals 4,500 meters. 4,500 meters is 4.5 kilometers. Therefore, 75 meters per minute equals 4.5 kilometers per hour. We did not use the factor 3.6 directly because the starting unit was meters per minute, not meters per second. Now consider a more unusual example. Suppose grass grows by 8 centimeters in 1 week, and we want to express its growth rate in kilometers per hour. Grass is not traveling along a path, so this is a growth rate rather than an ordinary speed. Nevertheless, its unit has the same length divided by time structure, and the conversion method is exactly the same. We must convert centimeters into kilometers and weeks into hours. 1 kilometer equals 100,000 centimeters. Therefore, 8 centimeters equals 8 divided by 100,000 kilometers, which is 0.00008 kilometers. 1 week contains 7 days, and 1 day contains 24 hours. Therefore, 1 week contains 7 times 24, or 168 hours. The growth rate is therefore 0.00008 kilometers divided by 168 hours. This is approximately 0.00000476 kilometers per hour. In scientific notation, it is approximately 4.76 times 10 to the power of negative 7 kilometers per hour. The exact number is not the main point. The important part is the method: convert the numerator into the desired unit of length, convert the denominator into the desired unit of time, and then divide. For every conversion of speed units, ask 3 questions. What is the starting unit of length? What is the starting unit of time? Which units of length and time do I want in the result? For example, suppose we want to convert 99 kilometers per hour into meters per second. The length unit changes from kilometers to meters, and the time unit changes from hours to seconds. Because these are the familiar kilometers per hour and meters per second units, we divide by 3.6. 99 divided by 3.6 is 27.5. Therefore, 99 kilometers per hour equals 27.5 meters per second. In the reverse direction, 10 meters per second equals 10 times 3.6, or 36 kilometers per hour. By contrast, 75 meters per minute cannot be handled by the direct rule because the denominator contains minutes rather than seconds. 8 centimeters per week certainly cannot be handled by the direct rule because both centimeters and weeks must be converted. The physical meaning of unit conversion is simple: we do not change the actual speed. We change only the language used to describe it. A car traveling at 72 kilometers per hour does not suddenly begin moving differently when we say that its speed is 20 meters per second. These are 2 descriptions of the same speed. It is just like saying that 1 meter equals 100 centimeters. The length has not changed. Only the numerical value and the unit used to express it have changed. The same principle applies to speed. A conversion result should also make physical sense. When we convert a positive speed from kilometers per hour into meters per second, the numerical value becomes smaller. 72 kilometers per hour becomes 20 meters per second. Each meter per second represents 3.6 kilometers per hour, so fewer meters per second units are needed to describe the same speed. Meters per second also asks how many meters correspond to just 1 second, rather than how many kilometers accumulate over an entire hour. In the reverse direction, the numerical value becomes larger. 20 meters per second becomes 72 kilometers per hour. A distance traveled during each second accumulates over 3,600 seconds before it is expressed as a distance per hour. There is no magic in either result. The most important goal is not to memorize every possible conversion. It is to understand that a speed is a unit of length divided by a unit of time. Every conversion must therefore keep track of both the length unit and the time unit. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.